It's amazing how our minds can play tricks on us, especially when we're asleep. And I'm not just talking about those crazy dreams we all have. Think about the case of Kenneth Parks.
Yes.
He drove for miles, ended up tragically killing his mother-in-law, and get this, he was acquitted because he was sleepwalking. It makes you wonder what's really going on in our brains when we're not fully conscious.
It's fascinating, isn't it?
And that's exactly what we're diving deep into today with the help of Dr. Guy Leschner, a leading neurologist and sleep physician.
The pleasure to be here.
Today, we're unraveling the mysteries of sleep and sleep disorders. We're drawing some really interesting points raised in a recent conversation on The Diary of a CEO. So consider this your crash course on the science of sleep, but tailored to what we're all curious about. We'll be looking at everything from the ideal amount of sleep to the dangers of not getting enough, the complexities of insomnia, and even those strange things our brains and bodies do while we're out cold.
It's true. This conversation we're referencing covered so much ground. We'll be looking at the fundamental importance of sleep, the impact of modern life, and those sometimes surprising connections between our sleep and our overall neurological well-being.
Perfect. So let's jump right in. We always hear that the magic number for sleep is somewhere between 7 and 8.5 hours a night. But is that really true for everyone?
Well, that 7 to 8.5 hour range comes from large population studies, and it's a good starting point for most people.
Right.
But, and this is interesting, there's data suggesting that if you regularly sleep more than 8.5 hours, mortality rates actually start to increase.
Really?
Now, that doesn't mean too much sleep is inherently bad, but it could be a sign of other underlying health problems, or even the side effects of certain medications.
I see.
And even more intriguingly, it might be a very early, subtle sign of certain neurological conditions. Sometimes changes in sleep patterns can show up years before a formal diagnosis.
That's a bit counterintuitive. You'd think more sleep would always be a good thing.
It's true. It's not always as straightforward as it seems.
Yeah.
And when we talk about healthy sleep, we need to remember that it's actually quite individual.
Right.
Our genetics play a big role. There are documented cases, though rare, of families who function perfectly well on just 4 hours of sleep a night. No negative effects at all.
Wow.
And then there's the concept of chronotypes. Think of it this way. Some people are morning larks, naturally energetic in the mornings, while others are night owls. They really come alive in the evening.
Oh, for sure.
And this isn't just a preference, it's partly hardwired into our genes.
Interesting.
So while that 7 to 8.5 hour range is a good average to aim for, what's considered healthy sleep can vary quite a bit from person to person.
It's pretty mind-blowing when you think about it. We spend roughly a third of our lives asleep.
Exactly.
And as you said, we're still learning so much about it. Why is sleep so fundamental to our existence? What's the evolutionary perspective on this?
Well, the sheer amount of time we dedicate to sleep suggests it's crucial for survival. Evolutionarily speaking, being unconscious for that long would be a huge disadvantage unless there were some very strong benefits.
That's true.
Take dolphins, for example. They can sleep with only half their brain at a time.
Really?
This allows them to rest while still being alert to danger and keeping essential functions like breathing going.
That's incredible.
And the fact that almost all living organisms have a circadian rhythm, that internal 24-hour cycle, also points to sleep being a really ancient and vital biological need.
So it's not just about recharging our batteries in the same way we rest after a workout, is it?
No, not at all. We now know that sleep has a huge impact on our entire biology. It's crucial for a strong immune system, a healthy cardiovascular system, managing our risk of diabetes, and even how we experience pain. It's intricately connected to our mental well-being, impacting things like anxiety and depression.
Yeah.
So sleep isn't just downtime. It's a period of really intense activity that affects our health and how well we function every single day.
It sounds like something we should all be prioritizing, but what's the reality? What's the state of sleep in our modern society?
Well, unfortunately, the statistics paint a bit of a worrying picture. It's estimated that around 20% of adults are chronically sleep deprived. This means they consistently don't get enough sleep, often due to the demands of modern life.
Right.
And then there's insomnia, which is incredibly common. About 30% of adults experience it every year, and around 10% struggle with chronic insomnia. That's difficulty falling asleep or staying asleep for at least 3 months.
Those are huge numbers.
They are. And then you have sleep apnea, where people actually stop breathing repeatedly during the night. This affects around 10 to 12% of adult men and about 6% of adult women.
That's a lot of people.
It is. and a shocking 80% of cases in the UK are thought to be undiagnosed.
Wow. And I know there are other sleep-related problems as well.
Absolutely. Restless leg syndrome, that uncomfortable urge to move your legs, affects about 5% of adults.
Oh, yeah.
And even sleepwalking, which you might think is rare, occurs at about 1 to 2% of the population.
That's still a lot of people.
It is. It really shows the range of ways our sleep can be disrupted.
With all of this in mind, do you think as a society we truly understand how important sleep is? Are we overestimating or underestimating its role in our lives?
I think there's been a positive shift in awareness over the last decade or so. It used to be almost a badge of honor to brag about how little sleep you got. Now people are more aware of its importance, but I still think there's an overall underestimation of the profound impact sleep has on our health and well-being. And interestingly, there's also a growing group of people who might be becoming overly obsessed with sleep, getting anxious about reaching that perfect number of hours every night, which ironically can actually disrupt sleep.
Yeah, that makes sense. If you put too much pressure on yourself to sleep, it probably backfires. So let's talk a bit more about insomnia. You mentioned it's different from just being sleep deprived. What's the key difference?
You're right, it's an important distinction. Insomnia is when you have trouble falling asleep, staying asleep, or you wake up too early, even when you have the time and you really want to sleep. It's that frustrating feeling of lying in bed, wanting to drift off, but your brain just won't cooperate.
I think we've all been there.
Exactly. Chronic sleep deprivation, on the other hand, is usually because you're simply not giving yourself enough time to sleep. So someone who consistently works late or sacrifices sleep for other things might be sleep deprived, but they don't necessarily have insomnia.
Right, so they could probably fall asleep easily if they actually gave themselves the time.
Exactly.
And you mentioned that sometimes people who think they have severe insomnia might actually be getting more sleep than they realize.
Absolutely. We're not always great judges of our own sleep. In the sleep lab, we often see people who report only getting a couple of hours or even none at all. But when we objectively measure their brain waves, they've slept for 7 or 8 hours. Their sleep might be very fragmented, with lots of brief awakenings they don't remember, or might be disrupted by other things like periodic limb movement disorder or sleep apnea. So even though they've technically slept for a decent amount of time, they feel like they haven't slept well at all.
That's really interesting. So if someone is genuinely struggling with insomnia, what are the most effective ways to treat it?
The good news is that we have very effective treatments for insomnia. And thankfully, the most successful ones are often not drug-based.
Oh, that's good to hear.
Cognitive behavioral therapy for insomnia, or CBTI, is considered the gold standard. Studies show it can improve sleep in up to 80% of people.
80%? That's incredible. How does CBTI work?
So CBTI addresses both the psychological and the behavioral aspects of insomnia. It helps to manage those anxieties and worries people have about sleep. The fear of not being able to fall asleep, the dread of the consequences of a bad night's sleep, all of that.
Yeah, that makes sense.
But it also works on a more basic level to reestablish a healthy association between your bed and sleep. If you spend a lot of time in bed awake, that connection can weaken, and your bed can actually become a trigger for wakefulness instead of sleep.
Interesting.
CBTI uses techniques like relaxation training, sleep restriction, which means limiting your time in bed to match how much you're actually sleeping, to build up your sleep drive, and cognitive restructuring, which helps challenge and change negative thoughts about sleep.
Okay.
There are also more intensive sleep retraining techniques used in specialized centers, which involve controlled periods of sleep deprivation and strategically timed naps to essentially reset the brain's sleep-wake cycle.
So it sounds like a much more sustainable long-term solution than just taking a sleeping pill. You're not really a fan of those as a first-line approach, right?
I'm not, no. While sleeping tablets have a place in certain situations, especially in the short term, they don't address the underlying causes of insomnia and can have side effects and the risk of dependence.
Right.
The focus should really be on these behavioral and psychological interventions like CBTI.
Earlier, you mentioned the impact of lifestyle factors. How much does our modern way of life contribute to our sleep problems?
It's a huge factor. I think modern society, with its constant stimulation, artificial light, and unhealthy lifestyles, creates the perfect conditions for insomnia. When researchers look at pre-industrialized societies, insomnia seems to have been uncommon. Some cultures didn't even have a word for it.
That's fascinating.
And sleep apnea is strongly linked to weight gain, which is heavily influenced by our modern diets and more sedentary lifestyles. So there's definitely a strong connection between how we live now and the sleep problems so many people face.
What about the idea that as we age, we naturally need less sleep? Is there any truth to that?
It's mostly a myth. There might be a very slight decrease in our absolute sleep need as we get older, almost negligible. But the main issue is that the brain mechanisms that regulate our sleep become a bit less robust as we age.
I see.
So it becomes harder to maintain good quality consolidated sleep. This means older adults might experience more fragmented sleep with more frequent awakenings, but their fundamental need for sleep doesn't actually change drastically.
That makes sense. And you also mentioned a link between lack of sleep and weight gain. How does that work biologically?
There are a few things going on here. One of the key mechanisms involves hormones that regulate our appetite. Even just one night of insufficient sleep can increase hunger hormones and decrease the hormones that make us feel full. This often leads to eating more the next day. Studies have consistently shown that people who sleep less than 6 hours a night tend to have a higher BMI and are at a greater risk of gaining weight over time. Not only that, but sleep deprivation can also negatively impact our glucose metabolism and insulin sensitivity. This is directly linked to our risk of developing type 2 diabetes. And interestingly, sometimes even treating sleep apnea in people who are overweight can lead to weight loss.
So it's a very complex connection.
It is. It highlights the intricate relationship between sleep, metabolism, and weight.
So consistently not getting enough sleep can actually disrupt our whole metabolic system.
Exactly. It's not just about feeling tired. It triggers real physiological changes in our bodies.
Let's talk about our internal body clock, the circadian rhythm. What are the key things we need to understand about this?
You can think of the circadian rhythm as a 24-hour biological clock that operates in almost every cell in our body.
Wow.
And a significant portion of our genes actually show this 24-hour cyclical activity. This internal clock is responsible for regulating so many biological processes, from when our liver works most efficiently to the rhythms of our heart and even our behavior. It influences when we feel tired, hungry, and most alert.
I had no idea it was so widespread.
It really is. And the master control center in our brain is a tiny region called the suprachiasmatic nucleus, located in the hypothalamus. It's like the conductor of our internal orchestra.
Okay, and what keeps this internal clock synchronized with the outside world?
It's a combination of our genetics, meaning whether we're naturally morning or evening people, and environmental cues. Light is the most powerful cue, especially blue light.
Right.
But mealtimes, exercise, even social interactions play a role in keeping our internal clock aligned with the day-night cycle.
I see.
And melatonin, a hormone produced in the pineal gland, acts as a key signal of our circadian rhythm. It typically increases in the evening when it gets dark and decreases in the morning when it's light.
Okay.
And this is interesting. Taking melatonin supplements at specific times can sometimes help to shift our circadian rhythm, like when you're dealing with jet lag.
That makes sense. So what about all the blue light we get from our phones and computers? Is it really as disruptive as people say?
The current thinking is a bit nuanced. The amount of blue light from our devices might not be enough to directly cause insomnia in most people, but prolonged exposure in the evenings can definitely delay our circadian clock.
Okay.
If you're constantly on your phone or watching screens late at night, you're essentially telling your brain it's still daytime, which pushes your sleep-wake cycle later.
Right.
This can lead to sleep deprivation if you have to wake up early. Plus, the engaging content on these devices can keep our minds active and make it even harder to fall asleep.
It's like a double whammy.
Exactly.
What about those nights when you wake up in the middle of the night and can't get back to sleep? Is that always a bad sign?
Actually, it's pretty normal to have brief awakenings during the night. Most people wake up for short periods multiple times, often without even remembering it.
I had no idea.
Being awake for up to around 30 minutes total during the night isn't necessarily a problem. There's even some evidence that in pre-industrial times, humans might have followed a segmented sleep pattern with a first sleep and a second sleep, with a period of quiet wakefulness in between.
Really?
And in some cultures today, like in Mediterranean Europe, the siesta is still common, which could naturally lead to a different pattern of nighttime sleep. So there's a range of what can be considered normal.
You also mentioned sleep hygiene. What are some common things people do that mess up their sleep?
Poor sleep hygiene can include all sorts of things. Think about having your home office in your bedroom, constantly using electronics in bed, consuming caffeine or alcohol close to bedtime, or not having a relaxing wind-down routine.
Right.
These things can really interfere with sleep.
And what's the ideal sleep environment?
A bedroom that's dark, quiet, and cool is best. Darkness is crucial because light at night, even dim light, can suppress melatonin production. It's even been linked to an increased risk of metabolic disorders in some studies.
Wow, I didn't know that.
Blackout curtains or a sleep mask can help if your room isn't completely dark. Quiet minimizes disruptions, and a slightly cooler temperature is generally better than a warm one for sleep.
So it's all about creating the right conditions.
Exactly.
Let's talk about something I've come across recently, the glymphatic system. What exactly is that?
Imagine your brain has its own waste removal system, similar to the lymphatic system in the rest of your body. That's essentially what the glymphatic system is. It's a network of channels that run alongside blood vessels in the brain, helping to clear out fluid and metabolic waste products, the toxins that build up from brain activity during the day.
So the brain's own cleaning system.
Yes, exactly. Early research suggested that this system becomes much more active during deep sleep, playing a key role in clearing out substances like beta amyloid, a protein linked to Alzheimer's disease.
Wow, that's interesting.
However, more recent studies have raised some questions about exactly how much this activity increases during sleep. But the basic idea that sleep is vital for the brain's housekeeping and its health remains a very important area of research.
So in a way, sleep is like a nightly detox for our brains.
That's a great way to put it. It really emphasizes the restorative power of sleep, especially for our cognitive health and long-term brain well-being.
I love that analogy. So what about all those sleep trackers that are so popular now? Are they genuinely helpful, or do they just make people more anxious about their sleep?
It can be both, really. For research and for people who don't realize they're not getting enough sleep, they can be valuable tools.
Right.
However, for people who already have anxiety about their sleep, trackers can sometimes make it worse. The accuracy of these devices, especially when it comes to identifying different sleep stages and those brief awakenings, isn't always perfect. And just knowing you had a bad night's sleep without understanding why or how to fix it can be really unhelpful.
That makes sense.
The key is whether the information from the tracker leads to positive changes in sleep habits. If it just causes more worry, it's probably not doing any good.
It's like anything else. Information is only useful if you can actually do something with it. Let's move on to some of the more unusual aspects of sleep. We talked about sleepwalking earlier. What's actually happening in the brain when someone sleepwalks?
Sleepwalking and even more complex behaviors during sleep, like driving or preparing food, happen when certain parts of the brain are awake while others are still asleep.
That's so strange.
The areas that control movement, vision, and even emotions might be active, allowing for these actions. But the frontal lobes, which are responsible for rational thought and decision-making, and the hippocampus, which is crucial for forming new memories, are mostly offline. This explains why sleepwalkers often don't remember what they did.
It's like their brain is in this weird in-between state.
Exactly.
So what about dreams? Why do we dream? They often seem so bizarre and illogical.
That's a question that has fascinated people for centuries, and honestly, we still don't fully understand it. There are several theories. One is that dreaming, particularly during REM sleep, is crucial for consolidating memories and processing emotions.
Okay.
Matthew Walker, for example, has proposed that dreaming is a form of emotional first aid or emotional rehabilitation. Other theories suggest that REM sleep and dreaming are involved in brain development and learning new skills. It's likely that dreaming serves multiple purposes.
It's amazing how much is still unknown.
It really is.
And why do we tend to remember dreams more when we wake up directly from REM sleep?
That's another mystery. It's thought that the rapid shift from the highly active state of REM sleep to being fully awake might interfere with the normal process of forgetting dreams.
So it's like our brain doesn't have time to hit the delete button.
That's a good way to think about it.
What about nightmares? They can be so vivid and disturbing. Do they serve a purpose, or are they just a glitch in the system?
Well, from an evolutionary perspective, nightmares might actually be protective. They could be a way for us to process and learn from scary or traumatic experiences in a safe environment without the intense emotional response we felt during the actual event. It's almost like a simulation for dealing with threats and developing coping mechanisms. However, when nightmares become frequent, really distressing, and disrupt sleep, as we see in conditions like PTSD, it suggests that this processing mechanism isn't working as it should.
That's fascinating. So it's like a healthy way to process trauma, but sometimes it goes haywire.
Exactly.
You must have seen some really extreme and unusual sleep-related cases in your practice. What's one of the most unsettling things you've come across?
I have, yes. Sleep-related violence is particularly troubling, although thankfully quite rare. I've had patients who've been involved in serious incidents, including violence towards family members, while seemingly asleep. Trying to figure out what really happened during sleep versus wakefulness in these situations is incredibly difficult, both medically and legally. And beyond those extreme cases, conditions like Klein-Levin syndrome, which causes recurring episodes of excessive sleepiness, behavioral changes, and confusion, can have a devastating impact on people's lives. And of course, the case of Kenneth Parks, which we discussed earlier, is a powerful example of the potential consequences of sleepwalking.
It's amazing and a bit scary to think about how powerful our brains are, even when we're seemingly unconscious.
It is. There's still so much we don't fully understand.
You explore these complex neurological connections in your other books, too. The Man Who Tasted Words and Seven Deadly Sins, The Biology of Being Human. What's the overarching theme that fascinates you in these explorations?
What's always fascinating to me is the fundamental question of why we are the way we are. And from a scientific perspective, the answers always seem to come back to the brain. In my work, I meet people whose experiences of the world are profoundly different from what we consider normal, often because of neurological conditions. Whether it's the dramatic disruptions of sleep disorders, the altered perceptions of reality and synesthesia, or significant changes in behavior, studying these less common phenomena helps us understand the mechanisms that shape all our experiences, thoughts, and actions.
And synesthesia, where someone might taste words, that really highlights how differently individuals can perceive reality.
Exactly. It shows how much our individual experience of the world is shaped by the unique wiring and functioning of our brains. And when you consider cases where brain tumors or certain medications can dramatically change someone's personality and behavior, it raises big questions about free will and moral responsibility.
It's a reminder that the relationship between our brains and our experiences is incredibly complex. So as we wrap up this deep dive, what are the key takeaways you'd like us to remember about sleep?
I think the most important thing is that sleep is absolutely essential for our overall health and well-being. It's far more dynamic and active than we often realize.
It really is.
And it's influenced by so many things: our genes, our environment, our daily habits, even our mental state. While sleep problems are common in today's world, the good news is that effective help is available for most issues, often through non-drug approaches like CBTI. Understanding your own sleep patterns and seeking help when you need it is crucial for a healthier and better life.
And on that note, considering how intricate and often surprising the relationship between our brains and our experiences is, and how something as basic as sleep can have such a huge impact, it makes you wonder what other hidden biological processes might be shaping our daily lives in ways we haven't even imagined. It's a fascinating world to explore. Dr. Lichtsteiner, thank you so much for joining us today and shedding light on the mysteries of sleep.
It was my pleasure.
And for our listeners, keep those questions coming and keep exploring the amazing world of neuroscience and sleep. Until next time, sleep well.